Alright, so just to kind of finish up with this last example here, we factored it out into x minus 2 times x squared plus 2x plus 4. If you notice from the original question here, it was x to the fourth, meaning that I should have 4 different degrees, which I do because I have x plus 2 that's up here at the top, and then I have the x minus 2, there's 2 x's there, and then I have an x squared to give me that x to the fourth. Just to kind of give you a heads up about where we are heading with this as far as finding the zeros of polynomial functions, this would be a situation where you've got x plus 2 and x minus 2 that you can set equal to 0 and solve for. This x squared plus 2x plus 4, I can't factor it any further than that. So in this case, you would have to use the complete the square method or the quadratic formula to solve, and you would have 2 imaginary zeros here. So when you actually solve, you're getting, as a factor technically, x plus 1 plus I square root of 3, and then x plus 1 minus I square root of 3. So notice that if I put all of these together, and this is what you get if you solve using the quadratic formula. So we will look at more of these later. But if I put all of these together, here's a situation where I have a 4th degree polynomial, but it has 2 real zeros, x minus 2, x plus 2 gives me 2 and negative 2 for my zeros. And then I'm going to have 2 complex zeros because both of these parts have imaginary components to them. So that's kind of where we're moving towards with each of these. But just like we did with quadratics, we start with the factoring part first, and then go to actually solving and finding the zeros.